Hi everyone. This is Manish Kumar. This is our major project demo video with my colleagues Kanakam Tirumlesh and Kari Ajay. So our project title is about image processing for rats and pets detection in a healthcare and hotel industry using deep learning. So the main abstract of this project is about to develop an detection of rats and pets detection in a healthcare and hotel industry. So through the implementation of deep learning techniques, we are using a YOLO V8 algorithm to implement this project. So why we are using a YOLO V8 means it is the update version of the YOLO algorithm, and also it will detect multiple objects in a one picture. So that's why we are going to use the YOLO V8, and also data augmentation also we are going to use, because of if the images are in vertical means we can use data augmentation. So what is the use of YOLO V8 means it will combine the data augmentation, and it offers for the automated surveillance and monitoring systems. How it will be monitored means if the image contain any rat or pest or some other image also it will detect, and it will tell about this is a pest and this is a rat. So overall, the accuracy of the YOLO V8 is about 95%, not much accuracy, but compared to existing, it will give a better accuracy. Nowadays, real time applications are more hygienic, and environment must be safe. So what is the aim of the project means we are going to develop a deep learning based system for accurate of the detection of rats and pets in the healthcare and hotel facilities. Why we are going to using to develop this project means because of the environment must be health and hygienic, and also overall the environment must be safe in healthcare, and also the hotel must be also very hygienic. So what is the scope of this project means using YOLO V8 algorithm, we are focusing on the pets in the environmental conditions, and also we are going to apply the data augmentation techniques such as image clipping and also augmenting the data already training, and we have to improve the model. Next, the total introduction about the project is about the data set is already trained through the techniques of rotation, flipping, and zooming, and also it will prevent the overfitting, and it improves the generalization. How it will be improved means more efficient and reliable pest detection contains hygienic environment for the customers and patients. So the total combination of the YOLO V8 means in image processing, it will great promise for the revolution pest detection and management in the critical industries, and also it will unprecedented, it will accuracy and speed in the identifying and monitoring these unwanted pets or else rats. So these are the literature review we are collected through this literature, so we can collect our total project. And also we are going to use three modules. The first module is about data collection and annotation, and second module is about model improvisation, and third module is about creating the user interface. So the first module we are going to use the first step, data collection and annotation. So we are going to gather a data set of the images, and it will contains the rats and pets. Those images are collected from the healthcare and hospital, and the images must be in flipping means up vertical or horizontal. Not only vertical horizontal, it will normal pixel also we can take. So any kind of image we are going to detect, and such as the augmentation techniques such as rotation, flipping, scaling means here we are going to improve the model performance. It will detect whatever the image we are giving, but for that, we are going to implement the next step, image augmentation techniques. Here, there are two image augment techniques. What is that means? Here we are going to image processing in the identity in the detection of the rats and pets using YOLO V8. It means that rotation and flipping. Flipping means horizontal or vertical. It can detect, and also data augmentation techniques. It means it will develop a more robust and effective detection. Means it will identify some of the objects, not rats or pets. But while using a data augmentation, it will go for only the rat and pest. So this is the use of image augmentation technique. So this is the model architecture of the YOLO V8. Simply the conventional layer, first layer consists of 7 into 7, and second layer 3 into 3, and third layer 1 into 1, like that. These are the layers. Finally, a small pixel also it will going to give. So next, in this YOLO V8 architecture contains three three creations or three grids. One is a grid creation, bounding box prediction, class probability prediction. So this is the use of the YOLO V8. Means it will identify the bound box prediction. Because of in our project we are going to detect the image in a bound box prediction. For the purpose of detection, we are going to use this YOLO V8. So next is about data cleaning and standardization. It means that already the images are trained. While training itself, the image can the detection can automatically run because of how it will means either it is a missing value or as outliers. Such as techniques, the input data can remove those outliers and fill that missing values. Normalization. Normalization is nothing but removing the unwanted data. And it will give the quality of the data set using YOLO V8 framework. So next, step 5 is about the training data preparation. So how it will be trained means, so there are several key steps. First, we are going to take a highly quality data set contains image of rats and pets. So this data set can be pre-processed and annotated to the highlighting of the presence of the target animals. So whatever we are going to target means here we are going to target animals are rats and pets. So that is the purpose of using training and data preparation. So next, second module, model improvisation. What is the use of model improvisation means? So it is the completely different from first model. Means speed and accuracy is most important for the detection of the objects. For that purpose, we are going to use model improvisation. Here, data augmentation techniques such as scaling, rotations, the performance of the roller weight can be further enhanced or leading to more robust detections. It means that not only a single image, multiple images that will be detected in model improvisation. Next, module 3. So here we are going to create a user interface. First, the user can enter into the running part and it will give some of the training and it will going to detect the image, whatever the rats are page. So the web user interface. The web user is interface means we are going to give the input, just track the pets or identify the rats like that. Next, database. Whatever the data contains in our database, that will going to enter into the running part. The environment random rotation involves the rotating of the images by using of the pixel, and it will accurately detecting the rats and pets. So next, security. Here going to give a security for the detection of the classifying the pets and rats. Next, these are the standards and policies. means environment must be hygienic, safety, like that. So the implementation part, this is the total brief architecture of the project. First, we are going to collect the data, or the data must be in images, and the image on annotation means vertical flipping images. Data annotation means either it is rats or pets, different kind of. And then the image augmentation and pre-processing. If it is vertical means automatically here itself trained. And we are going to implement the our algorithm YOLO V8. And then it will trained. And then it will going to integration and deployment. What the deployment can be do here means, so here itself they can know what is the rat and what is the pet. If it is unable to find the images, how it will be means, it will again going to go for training YOLO V8, and it will come into again this integration deployment. If it is accuracy more than 95, clarity of the images they can find means, it directly go and detect. So this is the rat and this is the pest. So this is the data flow diagram. So as we camera and we capture the images and the data augmentation, and we are going to train the data set, and it will going to use the model YOLO V8. That or else we are going to direct give the input, and it will detect and it will classify. So and it will give finally the output. So this is the use case diagram, and this is the class diagram, and this is the admin diagram. This is a start and stop. So this is the sequence diagram. So healthcare facility and hotel management test detection, how it will be sending the images, and it will analyze, and it will notify. So whether it is rat or pest. So next time the hostel or the hospital or health hotel or must be safe. This is the ER diagram. So here going to use testings. We are in our project we are going to use three testings: unit testing, integration testing, system testing. So in our unit testing we are going to test three cases. First case is about image processing accuracy. The input must be a sample images with the various levels of the images. The output must be the pre-processed images, should be reduce the noise and construct, means image pre-processing techniques like color segmentation, color resizing, image resizing. Those are the image processing techniques. And then second test case is about YOLO V8 model initialization. We are going to use the initialization part of the algorithm YOLO V8. The output must be initialized without any errors and be ready for the training and inference. Next is about data augmentation effectiveness. So next about integration testing. Here we are going to integrate in the testing about surveillance system means hygienic, and then live video feeds are from the hygienic environment through the cameras. Like that we are going to take the video also we can do, but we are going to detect only the images whatever we are giving. And then system testing, alert mechanism, real-time monitoring, and performance under the different environmental conditions. Either it is a hotel or industry, any kind of environment we are giving, the image that must be detect, whether it is rat or pest. So like that, it will detect. This is the test results after the completing of the testing. So see here the multiple images are detecting in the simultaneously. Here a single pest, we can also detect the multiple and the box pixel also will come like that. So see, this is the input image, and this is the output image. So like that it will detect. I will show the execution part also. So finally the conclusion is nothing but we are going to detect the rats and pets, whether it is health care or hotel industry or any kind of environment must be hygiene with the accuracy rate increased the 95.8. So the application of YOLO V8 real-time detection tracking the pets with improved speed and precision. So the existing is nothing but CNN. It can only identify the image and not only multiple images. It can identify only the single image, not multiple images. So this is the problem of disadvantage of the existing CNN. That's why we are going to use YOLO V8, the future enhancement. So finally, the future must be hygienic. It will going to detect the integration part of the thermal imaging also. It means that while entering into the pets or rats in a healthcare, it will automatically go and detect. It will be integration part of the any images and also modalities facilitating detection under the challenging of the researchers. So these are the some references. Now I will show the execution part. So this is the YOLO V8 streamline. I prepare all must be I prepare like a app and I will going to show that. So this is the complete code. So this is the complete code. We are going to uh, use some of the libraries like that path PLI means image. So that's why we are going to use PLI module and Streamlit as AST. So these are all coding. We are done and I will show the execution. If I give CMN and it will directly go to the Python 8 version. And here we are going to give the command line Python underscore md mrstrm stream. So that is the module name streamlit run. Yeah. So I all put into the app. So that's why I'll press enter. It will connect directly. It will go to 1 minute. So Python underscore strem stream lit run app dot py. So it will directly go into the web page. So this is the user web page I am going to detect and I will create this user interface. So see here, we are running the user interface. And now I am going to, this is the default. So now I am going to give any one input, either it is pest or rat. And suppose I will give the input as a text and it will uh, so see this is the uploaded image means input image. Now I am going to detect see here the interface is running and see this is the detected image and also it will tell this is the pest like that. Suppose if I giving any other image or it will be rat. Hmm, see I am giving the multiple images of the rat. Check once. So this is the rats. So I am going to detect this. See, these are the multiple images. Here I am going to select 40% of the model confidence. If I give 60 or 50, it will going to detect whatever the bigger images that will only going to detect. Okay. See, see here also there will be rat, but it will not detect because of the model confidence I put as 50. If I am giving as 30 or some as 28, now I am going to detect this Even a small image. See, here itself there are four rats. In before 30 confidence, they will only detect the three rats only. But now the confidence level mean below means it will going to detect there is a small also. So now I'm going to give another image like vertical. If vertical means or else horizontal flipping images. Now see, this is the vertical images I uploaded. I'm going to detect this. See, if it is vertical also, it will get detect and it will say as rat. So this is the total project about our execution part. Okay, that's all. Thank you.